Hello, mentors. In meeting trees, this challenge is called Scale It Down. It's one of the motive challenges from part one. And it says, draw your symbol or your motive in the canvas, estimate how much percentage of the canvas it covers, so how much area relative to the total. And then in the same canvas, you will duplicate your symbol, so create a copy, but now scale down to 25% of the original. How can you check how close you really got to a perfect 25%? Which strategies could you use? So what students will do is they have their motive. And so let's annotate a little bit, which they'll draw. So let's say they had something like a rectangle along with, say, a triangle here and another triangle here. That's their motive. They would have to, after drawing it, estimate what's the percentage of the canvas it cover. So here it looks that it's small, right? So they could, for example, they could say that it's less than 25% because it actually fits in one of these fourths. And then they could use different methods to estimate, which we'll see in a minute. And then they would duplicate the symbol. So they'll just put it somewhere else and try to make it smaller so that it's 25%. And again, there's many methods. They could just eyeballing, try to make it so that it's a fourth. Or they could use some more sophisticated methods and talk about the axis. And actually, they could scale it to a half in the horizontal and vertical axis. And actually, that would mean that since a half times a half, it's a fourth, that'll be a fourth its size. So lots of different methods and approaches to do. Remember, this is like a lab, so a lot of experimenting and not like right answer and right approach. There's many approaches. What you're trying to do is make the students make better and better approaches each time, in the sense that they're more solid, they work more, and they're more general. They can be expressed more general. Also make visible all the general properties that make these approaches work. Let's take a look at some of the approaches that we recommend, and there's many more. So say this would be the original, and this would be the scale copy. As far as estimating or checking the percentage of area that it would cover either the original or the scale copy, they could, for example, approximate the motive to a rectangle. So that would mean covering this covering this motive with a big rectangle in a minimal way. Oops, let's make it the smallest rectangle such that the motive fits. And then try to make sense of the area of this whole rectangle. And then you could stop there and that's an approximation. Or actually say, hey, we can actually remove these rectangles and so on. So it's a very flexible method with many different ways to complement it for the level of accuracy. Remember that this is a 20 times 12 grid. So it has 960 mini squares, almost 1,000, right? So they could also use this numerical tool to conclude things about areas. What else could they do? Well, they could also cover the whole motive with lots of 1 by 1 unit squares. And in the homework, we have such a problem. So they would just use this grid. Let's use the line here and cover the whole shape with squares. They don't need to use the unit squares from the grid. So that's something important. They could use either smaller or larger squares, depending on the motive. They may need to use finer things, or they could just be happy with things that are not fine. And this can be done as I'm doing it, just drawing, or actually mentally, if students are good with counting, because you could count fast rows or columns of squares if your motive is kind of simple. So what I'm doing here is making a grid of these minimal, right? The minimal squares that I would need to cover the shape. And look, I can be flexible and say I'm not counting these squares because it's outside, right? Right. So if I delete these mini squares, I'm not covering the whole shape. But this is so marginal, this is so small, say for these parts here on the bottom, that I'm just not gonna care about it. And then they would start counting the squares that really matter, 1, 2, 3, and so on. And say, hey, that number of squares, it's a good approximate of the percentage relative to the 960. They could also do fancy stuff like these and these will count as just one, because together they almost complement as a whole. So mentally move around, shift around. So again, it's not just one way that's rigid, but area thinking, reasoning about area. That's what matters. That's what we're doing in the meeting. And for that, you need to be flexible and say, hey, I'm gonna be doing this in this situation because it helps. So it's a very nice skill. What else could we do? Well, let's keep trying. We could also use known formulas and a physical ruler. So let's not forbid that kids maybe know the area of a circle or the area of some triangle, etc. That's knowledge, that's information. And if it helps, go ahead and use it. So they would be measuring, for example, here they would measure the diameter or the radius, right, of the circle, probably relative to this grid. So the diameter looks like 1, 2, 3, 4, 5.5, say, maybe a little more. So the radius is half of that. And then you duplicate as after finding the area. And then you can check here the same and jump to some conclusions. So, and this would work when you have really, really basic shapes that you know the area of. What else could be done? Well, many things, but the last in our manual is how many times logic. So the how many times logic goes like this. Forget for now about this scale copy. Let's just worry about the original. It goes like, how many times would I need to copy paste, right? Duplicate, make copies of my original shape inside the canvas to cover the whole canvas. Of course, I cannot do that unless I have really nice rectangles or triangles, that things that tile the plane or tile this big rectangle, big canvas. But even if I cannot do it, I can think about it. And so let's do it. So 1, and I can, for example, say if I have symmetry like this original, I can ask the question I just asked, not about my motive, but about some part of my motive that I know the area relative to the whole. So for example, this is half the motive and the area is exactly half of the area. And I'm just gonna maybe use tracing paper, see how many times would I cover. So this should be equal circles. So I'm not making them equal, but they should be equal or almost equal. It's an approximation game. And then I would get a sense, okay, I need maybe 10, maybe more than 10, blah, 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 things like that. And then I would divide by 2 the answer, because the question is about my original. Again, you see that this is very motive dependent. So which approach to use, which logic, which strategy may depend heavily on the actual shape of the motive of the students. And that's really cool, because then it's like, hey, my motive really matters. It's not just one size fit all approach. So that's the video for this nice task. I hope you have fun. Enjoy. See you in another video.